Rising up from the concrete floor and glowing hot inside at nearly 2,000 degrees, this giant of a machine has stood here nearly as long as Rocketdyne has been in business, around 43 years. It has brazed and heat-treated hardware that helped send men to the moon. The Pacific Furnace helped to build both the F-1 and J-2 engines for the Apollo Saturn V launch vehicle and every space shuttle main engine to date. This furnace was key to the brazing of the unique linear aerospike engine, resurrected in the 1990s. The NASA-owned furnace is such a unique and important piece of equipment that, like the space shuttle, it is considered to be a national asset. It's certainly the only furnace of its kind in North America, and there may be only one or two like it in the world. Brazing is a process of the joining of materials by a layer of alloy that has a lower melting temperature than the materials to be joined. The brazed material wets upon melting with a melting point that is higher than that of solders. During the brazing process, the workpieces are placed in a furnace and heated to the brazing temperature. Today, the furnace is used for brazing the Space Shuttle main engine nozzle tubes together. A braze of an SSME nozzle is a meticulously monitored process. The control room for the furnace went through a series of improvements, but the control panels still look like they stepped out of a movie set from 50 years ago, and indeed many of them are still the originals. The venerable Pacific Furnace has undergone a series of upgrades that enhanced its capability, including a self-monitoring system that uses an ultraviolet sensor to determine if the pilot light is lit and shuts the system down if none is detected. 24 more efficient burners have replaced the original 48. The new burners are positioned at 30-degree angles. This forces a vortex inside the furnace, which results in better distribution of the heat. A new retort, or canister, replaced the older version, which was at the end of its operational life. The canister is mounted over the SSME nozzle and welded shut prior to a braze run. It ensures that the proper atmospheric environment is maintained during the heat processing. The technological value of the Pacific Furnace has been evident in its performance over the last 4 decades. A rocket engine nozzle is a complicated piece of hardware, and every tool that helps improve the process is critical. Although the relevance of this furnace will end with the delivery of the last SSME nozzle, its historic value will live on with the legacy of a program as vital as the Space Shuttle.